Hello, student. Myself, Dr. Ishad Ahmed Khan, Associate Professor, Department of Mechanical Engineering, Sagar Institute of Research and Technology. And today we are going to discuss about this particular subject, what is the strength of material, and under this particular subject, in the first class, we are understand about the load, its type, stress, and strain. So this is a basic class. So we can let's understand all this terminology. So what is the strength of material? So simply, this subject is also known as mechanics of material. Is a subject which deal with the behavior of solid object subjected to stresses and strain. So how stresses will produce when you apply the external load. So stress and very stress develop. So the effect of that in terms of um, uh, material change its behavior. So we can say that it's produce the stress. So another we can say also define strength of material is subject which refer to the various method for calculating the stress and strain in structural number such as beam, column, and shaft, and the method employed to predict the response of a structure under the loading condition. So, dear student, particular in the subject, you can simple understand like this. In this particular subject, we are considering our machine element or a structural element are static condition. Structure is already static condition, but machine where you are analyzing the applying the concept of strength of material, so it's also a static part. So this, with the help of this subject, we can able to find the what kind of material we choose for designing a machine component which can sustain the that much of load and material or that particular component give the long lasting. So this is the object. So objective of this particular subject. So let's move ahead. So basics few definitions of the load. We can see a load and it's a type also we can see here simply. We all know all and understand about the what is the load. So we can say load is what? It's a set of external force acting on a mechanism or engineering structure which arise from service condition in which the component work. So when any machine component or a structural component it is in used, then it can using. So there is that some uh, force are generated. So that is called the load, and the component of various load is there. Common type of the load in engineering applications are tension and compression. Uh, you you can understand very easily. So tension, what is the tension? What is the compression? So in tension, you can simply understand that if you apply the direct pull, like suppose this is an object, if you apply direct pull like this, you just pull this. So what happened? So what this material experience? So that is called tension and compression. You just apply the to push. You just push inside it. So what this experience is called the compression type of load, and sign convention when we are pulling it out, pull outside. So this is we can represent by the positive sign, and an opposite of that when you push when inside like this. So this is called this is represented by the minus sign. So type of load. So we can say we all know that dead load is static load. In dead load, no fluctuating force, generally caused by the gravity. Like I am sitting here, okay, like this. So I am applying my static load on this chair. Or when you are standing somewhere, not moving, so you are applying your static load on that ground. Okay, so in dead load, there is no motion, there is no fluctuation. Live load, due to dynamic effects, you can say, when you are moving on somewhere, so you are applying the dynamic loading. Like example, the load exerted by bus, which is you know flying on the road, on that particular on a bridge. So that load is called live load. Okay. So impact load or shock load due to sudden blow. You are in the first floor and that 5 kg of stone is just dropped at the ground. So what the impact which produced on that ground, that is called sudden load or impact load. Okay, fluctuating or we can say fatigue load, or we can also known as the alternating load. So what is that? The magnitude and sign of the force changing with time. So both time, magnitude and um, time, sign of the force are changed with the time. So come under this fatigue condition. Okay, many machine components. Suppose a rotor is, suppose this is a rotor. Some pulley is there, some sprocket is there, or many other arrangement is are already mounted on this rotor, and it's moving 200 rpm. So at the time when it is moving, the magnitude and sign of force changing with the time. Okay, it is changing on that. So this experience, what this rotor will experience, that kind of load is called fatigue or fluctuating load. And some might be somewhere in eccentricity is available on this shaft. This can also be such kind of load can be experienced by this. So this is called fluctuating load, and this kind of load is very dangerous because due to the fatigue loading, material fell before their actual predicted life. So this is you can say understand the types of load and definition of stress. Simply we can understand. You can see, my dear student, this is a specimen you have already applied. This the pull. This pull on this particular this specimen. So what this part, suppose this cross sectional experience internal resistance, so that is called stress. So let's understand by definition. The force of resistance per unit area offered by a body against deformation is called the stress. Yes, force of resistance when you force apply, so this part is resisting a force. This part is try to be held together, this material. So this called stress. External force acting on the body is called the load or force. The load is applied on the body while the stress is induced in the body when the resistance offered by the material against the deformation and applied are equal to the loaded material is said to be equilibrium condition. The simple understand that, my dear student. So if you load here applying here and in this both the both end, so this part is a produce extra internal resistance. So the till this is not break or there is no deformation, so material with is said to be in under equilibrium when this applied load at exceed that produce here internal resistance. So it is starting the deformation, and after the deformation you can after the ultimate point and the making will start and finally material will break. So you can say, so this particular this particular cross sectional area experiencing experiencing stress, and stress basically it is developed due to the internal resistance offered by the material which tried to keeping in that particular position, initial position to that material. Mm, and till the equilibrium, both applied force and internal resistance are equal. That's why we can say P upon A. Let's see in next slide. So we are already near the, this is what the load this is load applied, and this is also the internal resistance developed in this particular material till the equilibrium. Both applied force and resistance developed in that material are equal, so we can directly write load upon area. But in actual definition, the force of resistance per unit area is called the stress, because the till the equilibrium condition, both applied load and internal resisting force which um, develop inside the material are equal, so we can directly write this equation in this way. If so, what will be the stress? This question for you. If this is the 100 newton and the cross sectional area of this cylindrical object is 100 meter square, so what will be the stress? You can say you just divide by just divide the 10 to this. So P by A, it is become 100 Newton per meter square, and Newton per meter square also called a Pascal. So we can say 100 Pascal. Okay. So this is simple way you can calculate the stress in a object. Strain. So strain, when a body is subjected to any external force, there is some change in dimension of the body. The ratio of the change of dimensions of a body to its original dimension is known as strain. Strain is a dimension, of course, because suppose this is an object. I apply the load here, and suppose the initial length of this is 15 centimeter. Okay, and just we apply the force, and after the application of force, it is increased 15.335. So what will be the stress? 15.3, the change in length. What is the change is occur? So 15.35 minus 15 upon the original length, you can say the 15. So what the value will come, that is called the strain. And strain is a dimension responsive, because the both numerator and denominator are the length, or the same unit, so the both are cancelled, so it's become the dimension responsive. So tensile stress, compressive stress, volumetric, and shear stress. You can understand. Simple concept. What will be tensile when you apply the tensile load? What is compressive strain when you apply the compressive? Volumetric in the when the change in the volume, and shear strain, it is due to the shear force. So when you apply shear strain. So tensile, like understand with this tensile strain, ratio of increase in length to the original length of the body when subjected to direct pull. Already we discussed that. Compressive strain, ratio of decrease in length to the original length of the body when it is subjected to the push. I think you are getting, because we are already discussed about the type of load. You relate with the load, so you will understand this. So volumetric, the ratio of change in volume of body to the original body. Okay. So suppose you have suppose you have a ball, and you just uh, put in the a tank, um, and when the tank is inside the water, there is some the water pressure is applied on that. If the size of the ball is reduced by few by few amount, so we can say the change in the volume of that ball upon original ball, so you can calculate the volumetric efficiency from there. So in this way you can calculate. So type of stress, my dear student, you can also see the stress. There is a basically, we can say that two types, but the third one is the combined also, when the both effect is there. So direct stress or simple stress, indirect stress, you can understand. The shear stress, I'll be discuss what is the shear stress and normal stress. And indirect, you can say the torsional and bending stress, and combined stress when the combined effect will come of these indirect. Okay. So this is the combined. So my dear students, normal stress, it is also subdivided in tensile or compressive stress. So you just You can understand, my dear. Simply you can say with this simple diagram, compressive stress when develop when you apply the compressive load, tensile when you apply it on tensile load on an object, and already we have know that what is the stress load applied on that particular material upon cross sectional area of that, and uh, and shear stress you can see when like this, when I apply the load tangential to the resisting area, like this, so shear stress will produce, and torsional when apply ta- torque, like this, so torsional stress which develop, and bending like with this, and I apply the load like this, so one bending stress will develop. So this is simple different type of stresses, and depend on the loading condition it can be differentiated. So, type of direct stress, simply you can understand, my dear, that what is the tensile stress. Tensile and compressive, it is come under the normal stress. What is the normal state? When the applied load are perpendicular to the resisting area. So, this is called the normal stress. So, tensile stresses, it is a stress induced in the body when it is subjected to two equal opposite poles. We already discussed. So this is when the stress produced on that particular object, that is called tensile stress. So you can understand what happened. This is a small plate, and you are just applying this, and this is we are assuming that this cross sectional area, particularly this cross sectional area, experiencing some internal resistance, resisting force. So this resisting force is developed here, and this will generate in this part, and this resisting force, and both you can, if combine effect, you can say these two are trying to be counter these two applied load, so till equilibrium, so this R and P will equal. Okay, so you can understand simply resisting force upon cross sectional area, or you can say also the applied force upon cross sectional area. Tensile stress decrease in tensile, sorry, it must be an increase in length upon original area, there is correction, so I will do that. So it must be increase in length because the load is tensile in nature, not a compressive. Okay, so let's understand the second one, compressive. The same in the same fashion, you can say the applied load is compressive in nature. Then the direction of this is changed, and if in this you can combine both two, you can understand these P and R is equal under them when it is in equilibrium. So resisting force upon cross sectional area, applied force upon cross sectional area, both are the same to equilibrium, and decrease in length upon original length will produce the compressive strain and compressive stress. Compressive stress. So you can say the, and compression, it can be represented in terms of minus by minus sign. So you can say if and last one is the shear stress. Shear stress, you can say if shear stress into the body when the subjected to equal and opposite force which are acting tangentially across the resisting section. You can see, my dear student, this is suppose it is an object, or simple you can do anything. You can have a trunk or box in your house and try to be push this like this. So suppose you're trying to push and you have not that much of um, load, you don't not that much of power to be completely push that, so that part, this element part experiencing some kind of, this is suppose this base is fixed, so upper part it is experiencing some kind of the stress that is called the shear stress, and always this applied load is the parallel to that particular resisting area, what tangential or parallel you can say across the resisting area, which tend to the shear of across this section. I think you are getting my point. Like you can do that. You can see, and I fix that and try to, initially, and try to be push like this. So in there, if I do this, so there is some initial position is here, and now it shift toward that. So what happened? So then this angle, it can be represented by this angle, and that angle is called shear strain, and it is a very small angle, so we can directly write in terms of phi and tan phi is equal to d, this displacement of dd and this length, how much? So directly you can calculate the shear stress. So we can, in the coming class, definitely we will get in more detail on that. But initially, hope you are understood about the load, type of load, what is the stress, what is the strain, and their type. So thank you so much for attending today class. Okay.